it's very similar to what we were doing yesterday. We're given a table, and we have to come up with a function, and a correlation coefficient isn't a bad idea to use that also, but really we're going to be using that function to make a prediction. It says predict how much money is going to be in this person's account in a year that's beyond what our table says. So we were using Desmos yesterday. Go ahead and get out your computers and go to desmos.com. It's listed up there, esmos.com. As a little bit of review, to even get to where you can start typing in a table, you have to click on that plus sign up there, add item. Remember that from yesterday? When you do that, it gives you some things you can add, an image. We're interested in adding a table. So you would click on table, and then you'd have a blank there. And then filling in these numbers. Of course, the table that you're given on the worksheet is horizontal. So it has X on the top, and then across from it, it has these things. You can't do that horizontal in Desmos. So just make sure that everything that's across from the X on your worksheet is actually underneath the X on Desmos. Once you've got that filled in, and if you don't have it filled in, don't worry about it. The important part is when you get to the worksheet and you're doing it on your own. Because I already have this typed in as well. So we typed in this equation, but put the squiggly line, a tilde, in place of the equal sign. And that was letting Desmos know that we're not telling it something to graph. We're asking it to come up with an equation for our table. And so it came up with an equation. The A and B values are listed below, and it's our job to just take these values and plug them in for A and B. Just a little thing that you want to make sure you're doing. It says y sub 2 and x sub 2. That's in case if you have multiple x's and y's, like in my Desmos here, I have this top table, but then I have another one. You got to make sure that if it says y sub 2, x sub 2 here, that it matches exactly x sub 2 and y sub 2 on your table. So I'm going to go ahead and copy my A and B values onto my worksheet. A value was 513, and rounding to 2 decimal places, 2 digits behind the decimal, I'll say 0.92. My B value that Desmos calculated was 1.06. And it's good to know the correlation coefficient. Here's your answer to your warm-up if you didn't get it, because the correlation coefficient tells you how well of a fit, or how well the equation fits the data. So our correlation coefficient, the R squared, is very close to 1. R squared, 0.9979, which means this is a really good fit. This line fits our points really well. But we're just going to go ahead and fill out the equation. So it's a function starting with a name like f of x, and then setting it equal to a times b. Well, here's our a value. We're going to plug in 513.92. And then times b, so multiplied by 1.06. And then for an exponential equation, what's the very last thing we need to include in that function?
Square.
Not necessarily square it, but definitely raise it to some exponent. That's part of your answer. The other part is actually coming up with an actual number here. So it says predict the account's value in the year 2025. It says that this money was deposited in the year 1975, and it said that this graph covers between 1975 to 2015. And I think, yes, that's 40 years between those two dates. But we want to go 10 more years down the road. So what's the difference between 2025 and 1975? How many years have passed between those two? Exactly, 50. So if there was an extension on your table and you had a 50 here, we would be looking for this number right here. And we could plug in 50 right here, and it would tell us what that number is. But on some of these, you're going to be given not a year, but an amount of money, and you're going to be asked to figure out how long it would take to get there. So you'd be plugging in something here, and then having to isolate the x, which is not an Algebra 1 kind of thing. It's more of a college algebra thing, getting that x by itself. So we're going to do it the easy way. We're going to take a look at our graph. Going back over to Desmos here, these are all of the points in our table. And so that point that has an x value of 50 should be somewhere up there. If I click on the point, it tells me the x value, 39 or so, and then the y value that goes with it, 4,700 and some. Every single point on this line are points that make that equation true. And so if we go and click on this line and follow it up until our x turns into 50, closer. Oh, there it was. Right at 50. So across the bottom, our time is 50 years. That's our x value. And then the y value tells us how much money we have. So when we found this point is our answer. At 50 years, how much money do we have? Kind of hard to see. Some of you guys in the front can probably see it. But that 8,500, and I'm going to say 86. And it says how many dollars. And so I'm going to round it down to the 86. I think it was like 31 cents behind it. And then this is after 50 years. The very last one we're going to do together is given to us in a story, or at least in words, and we need to convert it so that it's a function that's in table form. So we're looking at this marine biologist monitors populations of catfish in a small lake. And he's got a starting point of 50 catfish in the first year. So let's go ahead and put our x and y. And we're going to say year 1 is our independent variable. And then depending on the year, it tells us how many catfish. So across from it, let's put the 50. What's the next year that it lists? Yeah, it goes all the way up to 4 and 170 that year. 6th year is 380. And finally, after 10 years, a lot of catfish. And you don't need to enter this into Desmos. I did it earlier. I'm going to turn off our first one that we're working with. Here is that table. Year 1, 4, 6, and 10, and the corresponding number of catfish. And I'm going to turn on the line for it. We don't really need the equation. It's calculated for us here. The main thing we need is the line that equation creates. And so we're going to go over here, and we're going to use this line. I'm going to zoom out. Looks like we've got these points right here, tracking our populations of catfish. And it's asking us, predict when the population of catfish will be 6,000. Is 6,000 our x value or our y value? Does it belong on this side or this side? Would the 6,000 go over here or over here? It's a y value, right? So let's go and look at our Desmos here, and we're going to find 6,000 on the y-axis. Once I've found 6,000, I'm going to go directly across until I hit, there we go, the point. And if you get it exactly at 6,000, that's great. If you don't, when we're visually solving this, it's going to be an approximation. And so how many years of the catfish population increasing will it take to get up to 6,000? And that point right there tells you it's somewhere around almost 13. 12.857 is the x value in front of a y value of 6,000. I'm going to round it up to 13. And we've got our answer. So today you're going to be entering those tables, but then using the graph that's created by it to line up either the x or y value, whichever one you're given. And then the point that includes that value is also going to include your answer. So I'll let you guys take a look at those problems on the back of your paper. Let me know if you have any questions.